Okay, everybody, welcome to the Monday, August 24th meeting of SIG apps. We have new demos, a few discussion items, and then bug scrub. So discussion item number 1 is failed pod handling issue for replica set controller.
Yeah, that was me. So I should probably.
Yeah, what did you want to do?
Right, so eviction. So when we evict pods through the eviction API, those pods get eventually deleted. But there's a case where kubelet evicts pods because they fail to match like the predicates on the node. And this should be usually avoided by scheduler checking the predicates first before it sets the node name and assigns the node. But there are cases where kubelet can still fail the pod and it is still left in the API because that's a different type of eviction. And there was the issue that I linked there from one of the users who was complaining that we don't clean those pods at all, right? And those pods are intentionally left there so user can find out why kubelet evicted that pod. But maybe we could clean them like after a week or some reasonable time. I was wondering what the opinion of the SIG on the matter was, because I wasn't decided myself.
Well, how do we do that without competing with the existing pod GC? I guess, I mean, they never get GC'd because they're actually left in a created but unschedulable state.
They're actually failed, right? And by pod GC, you mean the GC that cleans pods when we hit some global count?
Yeah, based on pressure thresholds.
Yeah, but those are like for the whole cluster, right? So
yeah, so, okay, so you're talking about is implementing something a bit more specific for pods with a status of evicted that would kick in more rapidly.
Yeah, specifically for the case of kubelet failing pods. So those pods are failed and they will never ever run, right? But we still care about kubelet not deleting them because that's the only way how you can find out why kubelet actually evicted it.
Yeah,
there will be like reason CPU or something.
Yeah, otherwise you just get like a magic disappearing pod, like, hey, I created that. No, I really
did.
Yeah. So is your thought to address this in the controllers individually, or to have another controller, or modify the existing GC? Like, how do you want to approach it? Is kind of my question.
Yeah, I think if I were to implement it, I would just create a special controller that would check all the pods that are in the evicted state and just check the timestamp of the deletion and clean those. And probably a flag on the KCM to choose the time. Like events are time-based as well, so this would probably be similar.
I mean, that totally makes sense to me. My only thing would be like it touches more than just SIG apps, I think, right? Like there's, well,
probably syncing with kubelet would be good.
Yeah, we could sync with kubelet, but honestly, if we're not asking Node to change its behavior, because really what we're saying is, okay, kubelet, you can keep doing like you've been doing, and we will handle any of these for you. And really, kubelet shouldn't be deciding when to. I don't know where you would put that in kubelet. That would make sense, right? Like that would just be a bunch of machines pounding the API machinery. I was kind of thinking of the scheduler interaction, but there really isn't one there either, right? Like once it's evicted, the scheduler is never really going to look at it again.
Yeah, the scheduler only looks at pods that don't have node names set.
Right.
And the issue is you set a node name. Sorry, Ken, go first.
I said this is going to be evicted and have a node name set, so it's not going to be a consideration for the scheduler. So it's not in any path for their code. It's not really in any path for kubelet code. But we wouldn't want to put it there. So we'd be adding another controller to controller manager that would that would manage the garbage collection. Currently, API Machinery pretty much owns GC outright, so we would probably have to sync with them.
Yeah, if you mean the general GC.
Yeah.
We own the pod GC, I suppose, which is closer.
So that's not clear, because when Janet was proposing modifications to Java and Pod GC, they were very involved with it, and I think they claimed ownership at the time. But I also think at this juncture they'd be willing to cede it if we want to take it over. So yeah, I guess we can sync with them. Does anyone else have thoughts?
Yeah, it sounds like we can sync with the API Machinery team for this GC behavior.
Yeah, that would likely need a cap, so that would probably be the syncing point when we show it to them, right?
Yeah.
Yeah. Okay, I will update this issue and have it in our backlog, I suppose, unless somebody's super excited to do it right now.
No, the only things that excite me are pod disruption budget, cron job, and staple set volume provisioning. Those are the things.
Yeah, this is pretty low priority. I just wanted to circle back and give some feedback to the user who proposed it.
Yeah, I mean, it sounds great. Like, I think it's a good idea too. So if we're willing to take it on as a cap and sync with API Machinery to get it done, it makes sense to me.
Cool. That's all I had. Thanks.
Antoine's not here. We'll put the bug scrub last after we get through the discussion points. He we want to talk about application CRD. We'll see if he comes on. If he pops on before we start the bug scrub, then we can see what he was thinking. This one was kind of interesting. So cost-based scheduling or scaling down of pods.
Yeah.
Is someone here to speak about it?
Yeah, I'm here. Can you hear me?
Yep.
Cool, great. So this is at least 5 years old issue which I found in the scheduling issues, and in short, when you scale down, you do not always pick the right victim, and when you pick a wrong victim, you can diverge from your scheduling plan or constraints, and eventually your pods are distributed the way that doesn't correspond with the scheduling predicate scores and so on. So this is about approaching this, and if you take a look at the issue closely, there's like a lot of discussion, a lot of ideas how to approach this, and I basically just summarized what was there, and I'm just suggesting that we use an annotation at the beginning. We annotate each pod. We rank the pod, like assign it a score, which will describe how much important the pod is. And then every controller will read the annotation and take it into account when deciding which pod should be the right victim. So right now, the process of deciding which pod is the victim is quite simple, and in general, control doesn't see entire cluster. So I also suggest that we run another component which will watch the entire cluster and run the pods. So there are actually to be two parts. The first one, where we will need to update every controller to take the annotation into account. And the other part, where basically we provide a default component, which might be the scheduler or like updated version of it, which will do the ranking And if the default component will not be sufficient, basically any customer or user of Kubernetes can implement its own component that will do the ranking. For example, in case there are some like proprietary solutions or for security reasons where the code just cannot be shared. So the if you take a look into the Google Doc, there's a link to the CAP where I describe the approach and the important bits. And the reason why I'm talking about this today is just to talk about if you think or feel that updating controls to read annotations is a right way or approachable way, or if you think that this can fly.
So let me ask one question. For the annotation, will the scheduler be placing the annotation? Like, who places the annotation?
It's going to be the new component, right? So right now, yeah, and the new component will try to use the scheduling framework and make the same decisions, or like that's the idea that the component will import the scheduling framework and try to be as much aligned with the scheduler.
Okay, so I'm trying to understand how this works. Okay, so let's say I have a deployment, right? Deployment creates a replica set. Replica set is scaled up. Each of these pods are created from the pod template spec in a uniform way, right?
Yep.
At some point prior to being persisted in storage, the pod's annotations are modified. Where does that happen?
Where? So if I understand the question correctly, we'll run like some form of the scheduler that will, right after a pod is created, the scheduler will read all the pods belonging to the same replica set, do the ranking, and then annotate all the pods.
And it'll update the annotations on the pods after the pod is scheduled?
Yes.
And before it lands on the node?
Well, it doesn't matter when it lands on the node because it's about scaling down. So
right, but I don't understand how it works because, okay, so if you're using hard spreading, like if you're using required scheduling predicates, then it just won't schedule in the event that you know, you can't meet the scheduling predicate as defined. But if you're using preferred scheduling, if you're using soft spreading predicates, then until it actually lands on a node, I don't know how you would compute the weight, right? If you're what you're really trying to do is spec spreading. So then, like, if you don't have, like, if it's not based on an actual topology of the capacity of the workload as it's spread across the cluster, I mean, it's not clear to me how that would work. From a controller standpoint, it would basically be opt-in, right? So like, if SIG, let's say SIG apps agrees to modify the controllers when we're selecting victims to take the annotation into account. Because I mean, the overhead doesn't look high. It would be a lot of work to get in there, and it would be something that would be a maintenance burden over time for sure. But it would simply be like when we're selecting the pod, we would look at a bunch of annotations. We're already aggregating most of the information pertaining to a pod in memory when we do a scale down anyway in the replica set controller. Aside from the risk inherent with bugs introduced in adding it, it probably isn't that bad on our side. And then if people are creating their own controllers, which would be my primary concern, like if other people who are doing like if you look at OpenShift operators, for instance, right? If they're creating their own custom workload controllers that already have knowledge about the topology of the workload that's being orchestrated and they don't want to opt into this, they can basically ignore the annotation and say, okay, whatever, right? And for us, we can wait until it materializes as an annotation that's actually introduced in a Kubernetes version before we start work at all, right? So we can get confidence. There are some nice properties there, but my kind of like with soft spreading, I don't see how the annotation would actually correspond to the deployment topology unless you wait till it actually lands on the node before adding the annotation. And there seems to be a lot of edge cases where, you know, it's going to be kind of probabilistic and best effort anyway, which if that adds value, and that's what I don't really understand. Like, if that adds value, if like we're making bad guesses and we believe that this cost-based accounting that's weighted based on the scheduling topology will allow us to make better guesses, I can buy that. But it's not clear to me exactly how that plays out in all the cases.
Can we always wait for the pod landing on a node, right? Because otherwise we just delete the pod in the API that doesn't actually have a container associated, right? So I'm not sure we care about that specific case.
Yeah, like it's true. I did not think about this case, but we can ignore all the pods in the pending state maybe, and
I think we delete pending first. That was what I was saying. So when we scale down, we always delete pending first, and then we choose firm running based on this annotation. That's my understanding of it. I read it a few weeks back, so sorry if I don't recall precisely.
Yeah.
Always delete. Well, I guess, I mean, if it's pending, it doesn't really count toward the topology anyway, but then again, you get that interaction with the scheduler, whereas if it's pending, well, no, I guess maybe that'll work. Yeah, okay.
Like, if you do not consider the annotation, like, can you always make a better decision? I mean, like, if you use the annotations, like, can it get wrong, or like, will you get a worse solution?
I don't see how it would hurt, right? Because
yeah.
So for stateful set, it's not going to matter anyway, in most cases, right? Like only in the burstable case, and then that doesn't really affect scale down. We always do like, yeah. So I don't think it matters for stateful set. For deployment, the topology, or I'm sorry, for daemon set, the topology considerations are probably quite a bit different, right? Because you're not downscaling replicas. Right, you're associating a pod with the individual node as the node is created within the cluster. So for those two controllers, I'm not sure that the applicability is very, like, I don't think we care as much. Like it's just not really going to affect the outcome. For the batch controllers, you're dealing with run to completion workloads anyway, right? Like these aren't things that you scale up and down or run forever. You may increase the parallelism, but there's probably not a lot of value to considering an additional annotation if you're playing around with the parallelism of a job that's running. If we even allow that, that's not a common use case that I've worked with, to be honest. So really we're talking about deployments, and when we're talking about deployments, the replica set controller and replication controller are the things that are actually scaling them up or down. So those would be the things that we care about. And like there is a valid case that it would be desirable for the end user that we could optimize for scheduling predicates. That's been a request that came back a while ago, but we really didn't want to, and this was in discussion with Node and scheduler, tie the logic for scheduling predicates tightly into the controllers, right? Because it breaks encapsulation and separation of concerns effectively. It's like not an awesome design principle for the system as we architected it. So this seems like very lightweight. It doesn't increase the barrier to entry for new people writing a controller because you can just ignore it and implement whatever behavior you have. And really, thinking about it, and you know, this could be wrong because it's just an initial assessment. It's really replica set and replication controller, and probably not replication controller because effectively the way the replica set and replication controller are implemented now, you'd actually implement it once in the code base and get it in both places. But you know, for those two, that's what we would care about. And if we can give better scheduling based on it, that's not bad for people who run small replica sets. I think the thing is, I don't know if the value is super. So like the idea behind replica set is you're going to run a large number of fungible replicas. And if you're really concerned about disruption, you increase the replication, right? So like if you want to probabilistically ensure that no zone or rack or whatever doesn't have sufficient capacity during an update, you tweak the max surge parameters and min available parameters, and then you tweak the replication to ensure that you have sufficient capacity to tolerate the planned disruption of a rollout. For scaling, how do you preserve it? You know, like if I have a spread for, like, let's say I have 3 availability zones or 3 racks, and I spread 5 pods across it, and then I scale down to 4. It's not clear to me what predicate I'm trying to preserve at that point. Like, you want an even spread, right? But if I scale down from, like, let's say 5 to 4, I'm always going to have some imbalance. I'm having trouble visualizing the use case where, you know, I scale down in such a way where I'm extraordinarily imbalancing the distribution of capacity for a particular workload across clusters. Can you give me some insight into that? Like, how does this occur? Like, when are we actually seeing a scale down disrespect scheduling predicates and cause an imbalance across clusters?
For example, when you have like you are saying 3 zones, each zone has like 10 nodes. You can just scale. You can scale down by 10, and if with unlock, you can just delete all the pods in 1 zone and left with all the pods just in 2 zones.
But does that actually happen?
I don't know. I don't have a real use case for it, but like it doesn't have to be 10. It can be like 5, just pods scaled down in the same zone. Yeah, like I don't have any like specific use cases or like customer issues dealing with that. So.
I mean, like the overall arching thing is like what we have now is at least hypothetically good from a standpoint of probability, that if you have, say, 3 zones, 10 nodes per zone, 10 pods per, or 1 pod per node, so 30 nodes, if you scale down 10, it's very unlikely that you get that non-uniform distribution of capacity across clusters. And then the rescheduler exists to actually fix things like that in the event that you do cause it. The downside to using a rescheduler-based approach is that you get 2 disruptions at the price of 1, right? So you scale down, and the rescheduler has to look at the distribution across the cluster in order to determine which pods to terminate in order to get them to go back through the scheduler to re-respect the scheduler predicates that were designed up front.
That's true, but like the scheduler is run like maybe every hour. It can be run every hour, not instantly. So you will be waiting 1 hour for the cluster to stabilize.
I think the issue.
Go ahead.
The issue also, and I think it was reported in one of the issues we own, was that the cost of scaling down the pod may be pretty high, right? Say you have a database that's only in memory and it's replicated there. And if you just rely on the scheduler and just kill the wrong pod and have to spin up a new one, that can be pretty costly, right?
For sure, and that's what I'm saying. Like the initial point was that what this buys you is a better decision about termination, about selecting a victim, so that you don't have to pay double disruptions on a scale down. You don't have to pay for the reschedule. I'm trying to like figure out how much of a problem it actually is for end users, though. I mean, like, so let's say it does take an hour for the rescheduler to kick in, and take the cost aside. If it takes an hour for the rescheduler to kick in, either like they're basically two scenarios. If you're spread across multiple zones, either when you scale down, you had an imbalanced cluster for an hour, but it wasn't really problematic because you didn't lose any additional capacity, right? The problem becomes if you completely eliminate one zone, then you get failure in another zone that's not that zone, which is somewhat unlikely, but let's just say that that does happen. Then you have to scale back up and rebalance across the two original zones, but you would have to do that anyway. So like from an availability perspective, I'm not sure it actually buys you much. I guess it's just primarily removing the cost associated with having the rescheduler put your pods back on the cluster. Yeah, I mean, it doesn't sound unreasonable to me, but I've been talking too much. Other people have thoughts?
Yeah. So I'm not sure we should use the annotation for something that the core Kubernetes controllers will react to. I think that point was made a while back on some other issue. So maybe this should be in the pod API. Have you tried investigating that part as well?
So like, I suggest like, so I suggest the annotation for alpha, and once it gets like promoted to beta, then I suggest that we use either a field in a pod status or a CRD.
The issue with alpha annotation is you just can't easily migrate over to beta and to V1, right? We tried a few years back with annotations and
It's so painful. Painful.
yeah. it looks good from the beginning, but when you actually try to migrate to the new versions, it pretty much sucks. And I think the SIG Arch decided we shouldn't do that in the future, right, Ken?
If I remember correctly, that was the decision. We could take it back up there. But I mean, like, so I guess at another point, what is did you present this to SIG scheduling?
Not yet. I'm going to start a discussion here.
So I would say this. I would definitely not block doing this. Like, advice I would give is, yeah, don't go with the alpha annotation. But we don't have to. If the scheduling SIG approves of this generally and wants to move forward this path, the controllers don't have to consume the annotation until it's basically stable, right? Like, you can have the alpha annotation in there or whatever version of the annotation in there and get the work done in the scheduler. And ideally, you would want it done in the scheduler first so that the controllers can consume something that's relatively stable in terms of API. And then, we could consume it once it's kind of in there. I would, if I was pushing this kept forward, I would get schedulers input first and make sure that all the implications behind scheduling are understood there. And like, if they're sold on the idea and they want to move forward with it, we can figure out the API semantics of how to do it later, I would say.
Yeah, like that sounds good. I just wanted to know if you like in general agree with this approach, like either to use annotation or a field instead of like, for example, using some webhooks or so.
Janet, you've been quiet. What are your thoughts?
I've been thinking about the benefit of this thing. I feel it's something that the scheduler could probably help. For example, when we create pods, the pods are scheduled by the scheduler. So if there's something that can help the controller to decide which one to scale down using the same logic, for example, it goes through instead of deleting a pod, it goes through something to decide through the scheduler to decide which pod to scale down. But I couldn't. I feel it's something that could live outside of the replica set controller. But I need to think about this more.
Makes sense. I get what you're basically saying. So you're saying that rather than invert control of scheduling decisions in the case of scaling and have the controllers have to deal with it, you have some other API than delete. Then the controllers use that to say, like, for instance, for this replica set and all pods selected by this label, I need the scheduler to select one for termination. And then the scheduler actually goes through and deletes it. So basically the controllers don't have to be concerned at all about scheduling predicates or annotations. It's just provided as an API that controller writers can use if they want to opt into this behavior.
Yeah.
Other than
exactly.
delete. Yeah, that makes sense too.
Are you talking admission, or are you talking like noting this in the API somewhere? Because I haven't figured out where yet, and having a scheduler or something deleted asynchronously.
Who are you asking here, Tomáš?
I was asking Janet. Sorry. So she proposed that we will have some kind of API that we will use and say, hey, delete 3 pods that belong to this pod selector, right? Basically. And we will note it somewhere in the API, or we will have an endpoint that's basically will do it live during execution of that call, right? And I was asking which of those she would prefer, or she was thinking.
So you mentioned admission, and what else?
So I suppose you could do something like an eviction API and have it on a replica set level, or you could just note it on the API object itself and wait for some external component to just choose those pods that belong to this selector, right?
Right.
Or if you could just describe what you thought in more detail, that would work too.
Yeah.
I think Janet also requested some more time to think it through. So
Okay, sorry.
I don't think any, like, she said, look, we should have a mechanism and described it. I said, oh yeah, and you could, I brought up the API concern, but neither of us, I think, have thought through completely like a mechanism that would do it, right? Like there are different ways, but yeah, maybe I think it's valid to say that, like, maybe the annotation isn't the right way to achieve the desired state, and we can discuss further either on the CAP or in another mechanism if we think that we should have an enhanced way to manage this so that the controllers don't have to deal with terminating the annotation or with respecting the annotation and without solving the problem today. But what I'm not hearing is a lot of pushback that I think there's questions like, how valuable is it? Like, how many users will it help? And, like, you know, how much impact will it have on the community if we do it? So from a prioritization perspective, there's some questions, but I'm not hearing anybody say outright, like, this is crazy and we shouldn't do it either. Is that a fair assessment?
I think it is.
Like, yeah.
Okay. So, I mean, go ahead.
Like, also to add to that, like, Brian Grant mentioned a few years back that the scheduler is, he knows, like, what's the best for the pods right now, but, like, the scheduler doesn't know what's the best for the pods like in the future. So like it knows what's right right away, but like after days, you can have completely different demands on how the pods should be distributed. So which is something that cannot be decided by the scheduler. So using another component that will include the scheduler decisions. The component can also include additional constraints which take the future into account, like metrics, for example, and based on those decide which pods should be scaled down. So it's just not about the cube scheduler. And also SIG scheduling like made very clear that the scheduler component is not meant to decide which pod gets scaled down. So it's like completely independent of that. So that's why I'm deciding like to build a new component.
Yeah.
And so on and so on.
Okay. So I think from to summarize what we've kind of the feedback we've kind of given so far, no one in SIG apps is saying that we're opposed to this idea in general. I think it's kind of clear what the objective is. There's some questions with respect to how many users are impacted by this and how valuable it would be for the community, but that doesn't mean we shouldn't do it. It's okay to do things that we think. Heck, all Kubernetes is something that we thought would be valuable and turned out to be correct, right? So it's okay to take a risk and do some things that we think will be valuable without complete evidence that it is. But from a prioritization perspective, supporting this over like cron job GA or PDB GA isn't something we're going to do. And then I think the feedback we can give. So in terms of whether it's the scheduler or another component that actually implements selecting the victim and terminating it, the mechanism that's required on the controller side, I think, is where we're collecting the most feedback. And a couple of members of the SIG have requested some time to kind of think through the idea of annotations, or whether there's a better mechanism in the API machinery that we could use to implement the interface between whatever component would take care of the descheduling and victim selection and the core controllers. I think the other thing is that we don't think this is probably applicable for stateful set. It's not clear what we would do here for daemon set, or if it makes sense. There are definitely topology constraints for daemon set that are very interesting, especially in terms of the update strategy for daemon set, which is something we've talked about for a while and something Clayton has an open kind of kept out about. But for this particular use case, it seems like it's really tied closely to the logic of replica set and replication controller, which is basically unified in the code base at this point anyway. So that's where it would touch. And we'll just, I guess, take some time to take a look at it and try to spend some time to give you thoughtful feedback and discuss whether we like the annotation idea or whether we would request a different API so that controller writers, and not just for built-in controllers, but as CRDs become more popular for anyone who wants to write a workload controller, are able to leverage it without an undue amount of burden for their development. Does that sound reasonable?
Yeah, absolutely.
Yeah, that sounds right. I have just two small points, completely not related to this, but generally. I mean, I agree with what you said, and I don't want to sound like I'm being against or anything. Just there is another enhancement we have opened for a while from somebody else in the community, and it was about the delete priority for controllers, which sounds pretty much similar to what Jan was presenting. So I think that's something we should consider as well. And in the end, there can be more than just one controller deciding the priority, right? So maybe something to consider for the next time is if those two could be merged together and how you could deal with multiple writers. Because Yeah,
Makes
I
sense.
posted a link to the enhancement into the chat as well.
And that,
So
that
you can
makes
find
sense.
it.
And then also that is like, I didn't try to push and dig deep into the scheduling considerations, but in theory, Kubernetes does allow for you to run multiple simultaneous schedulers. And like Thomas just indicated, if this was going to be something where you were trying, you probably have to think around, how do I run multiple simultaneous versions of this? Yeah, there are other scheduling considerations that we really didn't touch on here, but I think that would be a conversation that you're going to have with SIG scheduling too.
Yeah, definitely. I will talk to them as soon as I can, and yeah, like anyway, thanks for your time and for thinking about it, and I will try to address your comments as soon as I can.
Thank you. We'll give you the feedback on the CAP and try to open up a discussion about it. And thank you for your contribution. Okay. Antoine looks like he's on now.
Yep, I'm here. Sorry, I was. Hey everyone.
You're only a little bit late. It's cool. Okay. So what are you thinking about for application CRD?
Yeah. So first, yeah, I had like a lightning talk at KubeCon, so I propose if someone has a question about it, but I wanted to talk with the community about the future of the CRD and get your point of view about it. So is everyone aware about the CRD, application CRD, right? Oh. So yeah, as you know, it's to like a top level resource that was came out of the working group of definition to like collect all resources that belongs to one application, an entity. And it started as a CRD, and I faced like some challenge for adoption because of that. So for example, like few weeks ago, I wanted to integrate it with Kubernetes dashboard, and the answer was like, if it's a CRD, we don't integrate with it. And speaking with a lot of users was like also the same issue, saying, oh, I can't install CRD on my cluster or OpenShift cluster or everything. And basically, it's even on customize or toolings around packaging and managing application, that's a blocker. Like we can't be involved in something that is optional. Like we can't base our tools on something that maybe the user doesn't have. So now it's add an extra logic to say, is a resource exist or not, etc. So just keep like work around that and reinventing. I see customize have some things that is close to it, etc. built in, and make me think like, what do we want to do with this resource? Do we want to continue on that, or just like archive the projects? Is there a possibility to not be a CRD? Yeah, that's the main question I had for today. And just to finish, going back a bit to the context why it started as CRD, was the logic was like, we start as a CRD, and once there is adoption, we discuss if we want to have it core. But clearly, the fact that it is a CRD and outside, like not built in the installation, I don't care if it's core or not, but at least deploy with the distribution, it's a blocker for adoption, like a very strong blocker. So yeah, that's.
When you say it's a very strong blocker, do you mean lack of adoption is a strong blocker, or lack of being a built-in type?
A built-in type. Like the fact it's not built in, like from the feedback, it blocks adoption for the tools. They prefer just to build or for user also to get their own things that they manage themselves.
So Antoine, thanks for bringing this up. And by the way, I'm later than you, so you weren't the latest one to show up, I'm sure. I don't think it's going to be able to land as a built-in type anytime soon, though. because I think one of the criteria was proving use and success first. And so we don't have a lot of use yet, which is probably going to end up being a blocker. So we might want to try to solve that problem by coming at it from a different angle. And I think it's worth going after.
Agree with that, Matt, but I would also say that it's not clear to me from the SIG architecture perspective that migrating CRDs to built-in types is now a goal of the project anymore. It seems like the opposite is true, and supporting CRDs that live outside of built-in types as officially supported parts of the ecosystem is more the direction that the project is going. So if the blocker is being a built-in type, there might not be a lot we can do to address it. If the blocker is a lack of prevalence, that's something we can think about and see what we can do to get better adoption. Morton had reached out to the Helm community to see if it could be incorporated as part of Helm v3. From their perspective, it's like, okay, we'll do our own thing. You can use the application CRD if you want to, and there should be support for it. One of the problems that we found in experimenting with doing that, though, is that it's very clunky to kind of generate and use the application CRD there. For Customize, Customize has some issues with CRD support in general in terms of being able to, like, generating them might be something you can do. And we could look at like doing plugins for Customize to do application CRD generation, which was something that people were working on. For being able to mutate it based on a patch file, that's something that's an open issue that Anand actually opened against Customize recently, that's problematic to begin with. So there could be, one of the reasons that compatibility with Customize might be a thing is that CRD compatibility with Customize is kind of, it needs a little bit of love. Not much, but some. Successes, Google, Janet, you can speak to this maybe. I believe Google is using it inside of GKE and Anthos.
Yeah, we're using it.
So, I mean, one of the major distributions of Kubernetes for both public cloud and for cross cloud and for on-prem is adopting it. So, I mean, potentially, and they did give some publicity to it as well, but potentially leveraging that might be a good thing. The other suggestion I have that I didn't follow up on because it was other people who were primarily kind of leading the effort. I just tried to get some people in the room to talk. But there's some overlaps between the metadata associated with Operator Hub and application CRD. And one of the things we wanted to see that we could, actually, Antoine, I believe you were one of the people who was kind of involved in that conversation. Are there things we can do there where we can kind of either converge toward one thing or see how these can complement each other for custom controllers in Operator Hub? But I think it sounds like your issue might be more of a like globally UI and CI than kind of the back end side. Like I want Kubernetes dashboard to support it, and
yeah, but no, I completely understand that this is like the approach at least I've tried, and I say like I talk about a blocker because like I can make the, for example, the discussion for Kubernetes dashboard, and that's the same things when we talk even internally with OpenShift and or OLM is like it's not built in, so we prefer go our own way basically. It's too much trouble to rely on something that a user might have or may not have instead of owning the things themselves. So when, yeah.
Hey, Antoine, I like where you're going with this. Might I suggest, I'm willing to help work on it. We come up with a plan to improve adoption and try to lower the barrier for others to pick it up. I'm willing to sit down and work on it. If you want to get together, I'm happy to do that. But I think we might want to start trying to come up with an overall plan to increase adoption and make it easier or identify bottlenecks, that kind of thing.
Yeah, I'm completely done for it. And
okay,
let's maybe, as you say, maybe basically I need some support to at least reach out to committees and try to see how we can include that, and if it still makes sense to include this resource or not.
The other people, like I said, GKE and Anthos already has kind of bought into it. I think EKS and Amazon, like, very different. In talking to them, they're like, what UI, right? Like their version of like they don't have the same type of functionality that Azure and GKE kind of implement from a UI perspective. But we haven't ever talked to the people from Azure to see if maybe they would be interested, or IBM or Oracle, right? So like we have one major cloud provider that's adopted it. Having more than one might be a very compelling kind of use case for standardization, I would say.
Sounds so good. Yeah.
But the thing I don't know is dashboard integration worth it at this point?
So they close, like I linked the you mean dashboard integration with the application CRD?
With the open source dashboard, because so if you run most security scanning tools in a Kubernetes cluster and you're running the dashboard internally, it'll flag it as a security vulnerability and tell you to uninstall it. So my question is, like, is Kubernetes open source dashboard utilization growing, or has it come down to the point where everyone's using something like Octane or another dashboard for their Kubernetes clusters?
I actually don't know.
So I mean, because and this is just my impression, and I don't want to badmouth anybody who works on dashboard or badmouth the open source dashboard in general. But in talking to users in the community, it does seem like people are moving away from the open source dashboard because of the known security vulnerabilities associated with it. I think even under the GovSpec Kubernetes security standard list dashboard is something you shouldn't run. So I don't know if like that was one of the reasons why I'm just like, I don't know if we should push there for a tighter integration, just because it doesn't seem like it's something that's being invested in heavily.
Dashboards in general, I mean, if I'm being completely honest, are really hard because many of the distros are trying to provide a unique dashboard in order to have their business differentiator there, which means Kubernetes dashboard gets underinvested in, which ultimately ends up driving people to other dashboards. And it's hard to get movement on a truly useful one, or even know what useful is to whom, and create one. And so it's a complicated space. Yeah.
It's complicated. I mean, like, state of the art, as far as I can tell, at least my personal favorite, I should say, is Octane from Brian Lyles at VMware. It's nice because it does impersonation, and it restricts your access to the cluster based on the credentials that you actually present. It doesn't have to run, you can run it locally as opposed to running it in cluster. You can run it in cluster, and it doesn't have the same level of security vulnerability. So it's something that I can internally distribute in my organization and people can actually use without the security and trust teams being like, whoa, hold on. No. So, you know, but for OpenShift, they have a very, like you said, they have a very nice dashboard. GKE also has a very nice and well invested in dashboard. It's not clear that we're going to get the community investment unless we try to go out and build it. But I don't, the meta point was that, you know, I don't know if that route for application CRD is what we would want to push on so much as trying to get adoption of major organizations or people who are building tools for them. Like, it would be nice maybe to talk to Brian and see if like we could get some adoption in Octane, even though Octane does have some pretty good CRD support to begin with.
That's all good ideas. So maybe Matt, you propose to review a plan for maybe.
Yeah, let's come up with a plan and reasons for it. I can work with you offline on it.
Yeah, I think that would be great. So we can follow up on this. And
fantastic.
Thank you.
Okay. Well, we didn't get to a full bug scrub. We only have a few minutes left. So I would like to know if any, I didn't see anything that was a super high priority. It's burning right now. We need to jump on top of it bug. And we need to put some resources on it. Is anyone aware of any super hot right now? We need to throw somebody at it because it's burning bugs that we should bring up like in this moment. Okay, I will take that as a negative. Next time, because we didn't get a bug scrub in this time, we should definitely do one again. Last time we decided that we should probably get someone else to lead it if they'd like to drive. Tomas, would you like to?
Sure. I'm sorry I was unprepared the last time.
I mean, I kind of threw it at you right on the spot. It's not your fault if you don't want to jump under the bus.
Sure, next time sounds great.
Okay, cool. All right, so definite bug scrub for next time. Thanks everybody for attending, and thanks everybody for the contributions that they brought up or offered. We had some great discussions, and I'll see you in 2 weeks. If anything urgent comes up, you know, you can always hit us on Slack. Have a good one.
Thanks, Ken.
Ciao.
Yeah, thanks. Bye.